Welcome back, Syracuse Math Kitties. This is our very last video for Module 4. The Module 4 is the math packet dealing with properties of exponents. In the previous lesson, I showed you how the rules of exponents or the properties of exponents can apply to numbers other than powers of 10, right? So we saw that as long as we have the same base, all of the other properties still apply, right? So for example, we saw that, when you, I believe that the sample problem had, 1/3 to the, fourth power. And, so we understood that this means that, 1/3 is our base and we're going to multiply it with itself 4 times. Okay, and that's based on our very basic property of exponents where you have the base to the nth power and so that's our power or exponent, and that tells us how many times we're going to multiply the base by itself. Or we also had we also saw that when we have, for example, we saw that when we have 1/3 squared times 1/3 cubed, that, in this case, we have two bases that are the same. So our base is 1/3, and then we would just add our exponents. Okay, so it would be 1/3 to the 2 plus 3, which is same as 1/3 to the 5th power. Okay, and so we know this because this particular thing here, we know that because one of the properties of exponents is, when you have a power of 10 to the nth power times power of 10 to the mth power, that's equal to 10 to the n plus m, right? So the base is the same. Okay, our properties, we introduce them by using powers of 10, but we can see that those properties apply to different bases as well, as long as to the bases other than 10, right? So as long as we're dealing with the same base, so we have 1/3 and 1/3, then we can add the exponents. But what happens if we have different bases? So if you guys look at this right here, we have 2 to the 3rd power times 5 to the 3rd power. So in this case, clearly we do not have a same base. One base is 2, the second one is 5. So what do we do in this situation? Okay, so let me so this lesson number 8 just shows you what to do when you don't have the same base. So in this case, you cannot apply all of the same properties. So let's read this. It says, to multiply expressions with different bases but same exponent, we will multiply the bases and carry over the exponent. So for example, 2 to the 3rd power times 5 to the 3rd power. So we know that 2 to the 3rd power means that we're multiplying 2 with itself 3 times. So there's 2 times 2 times 2. Okay, so that's 2 3 times, right? And 5 to the 3rd power is 5 times 5 times 5. So we have 5 3 times, okay? So now we can regroup this because we have 3 2's and we have 3 5's. So we can regroup them and say that 2 times 5 times 2 times 5 times 2 times 5, okay, that we can see that the base is 2 times 5, and we're multiplying that base with itself 3 times. So that means that 2 to the 3rd power times 5 to the 3rd power is same as 2 times 5. So that's what the rule is saying. We are going to combine the bases and, you know, carry over the exponent, and the exponent is 3, so to the third power. So 2 times 5 to the third power. Okay, well, and then if we want to solve that, what is 2 times 5? 2 times 5 is 10. 10 to the third power is 1000. Okay, does that make sense, you guys? Okay, so if you go and if you look at these sample problems here, or these examples, you will find that you know, some of these let's just look at them. Okay, so select all the true statements. So here A, okay, we have 2 to the 8th power times 2 to the 9th power. So what are we dealing with? Okay, so in this case we have a same base. Okay, so are we going to be applying this rule right here? No, we're not, because this rule, rule number 5, is dealing with when we have different bases. So we have same bases here. So what do we do when we have two numbers with same base? We're going to add the exponents. And you can see that from up here somewhere. Hold on, let me find it for you. Okay, right here. When you have two numbers with the same base, you're going to add the exponents. Okay, so if we're adding the exponents, 8 plus 9, is that 17? That would be correct, right? So this is a true statement right here. So this is, I'll put a check mark on it. How about this one right here? 8 squared times 9 squared. Do we have a same base? No, we don't. So that means we're going to be using then this rule right here, because this is the only rule that's dealing with exponents where the base is not the same, but the exponent is the same. So what do you do with this one? Okay, well, you're going to combine the bases. So you're going to do 8 times 9, and you're going to carry over the exponent. Okay. Again, how about this one right here? 8 squared times 9 squared. That's pretty much the same thing. What did I do here? Oh, okay. Well, let's see. Clearly, one or the other is correct. Okay. How about this one right here? We have a same base. So that means we're not going to be using this rule. We're going to use one of the previous rules. Okay. So that's what you got to do, you guys. With each one of these, you have to decide which of the rules or properties of exponents you're using. And that's going to depend on whether the bases are the same or if the bases are different and exponents are the same. All right. And then just, look up which properties you are dealing with and, go from there. All right, if you guys need any help, if any of this is still confusing, please let me know. I'm here for you. You don't have to do it by yourself. Miss Piraino as well, she's here for you, and both of us will gladly help you. All right, take care of yourselves. See you next time. Module 5 coming right up.